In this video, we will discuss about the types of redox reaction and identification of oxidizing and reducing agent. So first at all, what is meant by redox reaction? Redox reactions are those in which oxidation and reduction takes place simultaneously. So we can say that in the modern definition of the redox reaction, which is more important to solve the problem, that redox reactions are those in which oxidation number increases and decreases. So in these reaction oxidation number decreases and increases. We know that increase in oxidation number, suppose this is -1, -2, -3, and here is +1, +2, +3. We know that increase in oxidation number is called oxidation, while decrease in oxidation number is called reduction. So when the oxidation and reduction reaction takes place simultaneously, these are called redox reaction. So we can take example of the redox reaction, that this is MnO4 minus permanganate ion when react with oxalate ion converts into CO2 and Mn+2. So the change in oxidation number of manganese is taking place like this. So it is decreasing in oxidation number from +7 to +2. So it is reduction. While in this, the change in oxidation number of carbon is from +3 to +4. So this is oxidation number. So because increase and decrease in oxidation number is taking place simultaneously, so it is a kind of redox reaction. Now, how we can classify the redox reaction? The first redox reaction can be classified on the basis of when oxidant and reductant are directly contact or not in contact. So on this basis, redox reaction may be direct or indirect redox reaction. Before this, we should understand the meaning of oxidizing agent or reducing agent. Simply, oxidizing agents are those which helps in oxidation. Yeah, we can say that more precisely, oxidizing agent shows decrease in oxidation number. This is very important definition to solve the problems, that oxidizing agent shows decrease in oxidation number. So these shows electronation. Means gain of electron. While the reducing agent, how we can define the reducing agent? Reducing agent shows increase in oxidation number. So in this reaction, because manganese, there is a change in the oxidation number of manganese from +7 to +2. So it is showing decrease in oxidation number. So MnO4 minus will act as the oxidizing agent, while the change in oxidation number of carbon is taking place from +3 to +4. So it is showing increase in oxidation number. So it will act as a reducing agent. Now, how we can define the direct and indirect redox reaction? In the direct redox reaction, as the name suggests, in the direct redox reaction, oxidation and reduction occurs in the same vessel, which means that in the direct redox reaction, oxidant and reductant will be directly into contact. For example, this is copper sulfate solution. And a zinc rod is dipped into this. Obviously, oxidant and reductant are directly into contact because the reactivity of zinc is more than copper. So the redox reaction which will occur, we can write as zinc plus copper sulfate. This will give ZnSO4 plus Cu. So there is a change in the oxidation number of zinc from 0 to +2. So it is oxidation. Since the oxidation number is increasing, and the change in oxidation number for copper is +2 to 0, because the oxidation number is decreasing, and decrease in oxidation number is called reduction. So in this reaction, the oxidation and reduction takes place simultaneously in the same vessel. So we can say that the oxidant and reductant, how we can identify the oxidant, which shows decrease in oxidation number. So oxidant in this reaction definitely will be CuSO4 because it is showing decrease in oxidation number. This is oxidant, the oxidizing agent. And zinc it is increasing its oxidation number, so it will act as a reducing agent. Now how most of the part of the energy which is produced in this redox reaction will be dissipated in the form of heat. Now what is indirect redox reaction? Obviously in indirect redox reaction we will carry out the oxidation and reduction reaction into two different vessels, and this is very important reaction because the total energy part, most of the energy part out of the total energy part is used to do useful work, and it is basically used in galvanic cells or basically galvanic cell or redox cell. So how we can carry out these reaction? Suppose this is ZnSO4 solution and the zinc rod is in contact with ZnSO4 solution, and in the separate chamber, separate vessel, a copper rod is in contact with copper sulfate solution, and these are connected through the salt bridge, and externally these are connected by the metal wire. So we are carrying out the oxidation and reduction reaction separately like this in the two separate chamber, two separate vessel. So this reaction is called indirect redox reaction. We'll discuss about the another type of redox reaction which is called intermolecular redox reaction. So intermolecular redox reaction means between the molecules. So between the molecules, one atom get oxidized and other is reduced. So we can say that for one oxidation number will increase and for another oxidation number will decrease. For example, zinc is changing the oxidation number like this. So this will be the oxidation, and copper Cu+2 to Cu, this will show decrease in oxidation number. So this will be reduction reaction. We can take one more example of this, like iron when react with N2H4 will give FeOH whole twice plus NH3. So this is intermolecular redox reaction because Fe is changing is the oxidation number from Fe0 to Fe+2, and in nitrogen in N2H4 is changing from -2 to -3. So this is oxidation because increase in oxidation number, and this is reduction because it is showing decrease in oxidation number. So because Fe is increasing its oxidation number, it will act as a reducing agent, and N2H4 is decreasing its oxidation number, so it will act as the oxidizing agent. It is to be noted that Fe is oxidized to Fe0 to Fe+2, so definitely the reducing agent is oxidized species. Reducing agent is oxidized species, and oxidizing agent is reduced species. So sometimes they can ask in the question to find out the oxidizing agent, reducing agent, reduced species or oxidized species. So it is to be noted that reducing agent is oxidized species while the oxidizing agent is reduced species. Now the third type of reaction is called intramolecular redox reaction. As the name suggests, intramolecular redox reaction. So we will observe the increase or decrease in oxidation number within the molecule. So within the molecule, one element shows increase in oxidation number. So one element of the compound is oxidized and other element of the same compound is reduced. To be noted that in the intramolecular redox reaction, we are observing two different elements in a single compound. One is oxidized, which means that one is increasing its oxidation number and another is showing decrease in oxidation number. One element of the compound is oxidized, so oxidation number increases, and another is showing decrease in is reduced, so another is showing decrease in oxidation number. Let's take example to explain the intramolecular redox reaction. So this is ammonium dichromate. So how we can find the oxidation number of nitrogen and chromium in this compound? So definitely nitrogen in this compound is in -3 while chromium is in +6 oxidation number. So -3 and +6. So nitrogen is changing -3 to 0. So it is oxidation reaction, and chromium is changing from +6 to +3. So it is reduction reaction. So oxidation and reduction is taking place within the compound and for the two different elements. That's why it is intramolecular redox reaction. Now we can take one more example. This is KClO3, and in KClO3 the oxidation number of chlorine is +5, which is changing into -1, and the oxidation number of oxygen is -2, and here is oxygen is 0. So Cl is changing from +5 to -1, so it is +5 to -1, so it is reduction, and oxygen is changing from -2 to 0, which is oxidation. So this is known as intramolecular redox reaction. Let's discuss another category of the redox reaction, which is called disproportionation reaction. It is to be noted that in the disproportionation reaction, one element in a compound is oxidized and simultaneously reduced, which means that in a compound one element increase and decrease its oxidation number. Let's take example to explain the disproportionation reaction. For example, H2O2 on decomposition will give H2O plus O2. So here oxygen is in -1 oxidation state, which changed into the -2 and 0. So oxygen in H2O2 is decreasing its oxidation number, so it is showing reduction. Also the oxygen is increasing its oxidation number, which is oxidation. So in the same compound, same element is increasing and decreasing its oxidation number, is increasing and decreasing its oxidation number. So this kind of reaction is called disproportionation reaction. We can take one more example. This is white phosphorus, which on reaction with NaOH will produce PS3 and NaH2PO2, sodium dihydrogen phosphate. So this is P4, which is in 0 oxidation state. This is -3 and this will be +1. Phosphorus is changing its oxidation state from 0 to -3, so it is reduction. And from 0 to +1, so it is oxidation, because the same element is undergoing oxidation or reduction, or we can say that the same element is undergoing increase and decrease in oxidation number, so it is a disproportionation reaction. We can take one more example in this, that MnO4 minus 2, which is magnet ion, disproportionate into permanganate ion MnO4 minus and MnO2. So the change in the oxidation state we can find easily. This will be plus 6 and this will be in plus 7 and this will be in plus 4. So manganese is increasing its oxidation number from plus 6 to plus 7. So this is oxidation, and the same way plus 6 to plus 4, it is reduction. So same element is undergoing change in oxidation number, means increasing and decreasing the oxidation number. So this is disproportionation reaction. It is to be noted that the reacting species which is showing the disproportionation reaction will be in its intermediate oxidation state. It is very important point. The species which is undergoing disproportionation reaction must be in intermediate oxidation state. We can take one more example of disproportionation reaction in which Cl2 is changing into different medium. This is OH minus and this is cold alkali, and we can say that it is hot alkali. So in presence of hot alkali, this will convert into Cl minus and ClO3 minus, and in cold alkali it will convert into Cl minus and ClO minus. Here is the change in the oxidation number. When you will observe, it is from Cl to 0 to here Cl plus 5 and minus 1, so it is disproportionation reaction. In the same way, it is decreasing its oxidation number and increasing its oxidation number. It is also the disproportionation reaction. So we can say that we can take X2 in the place of Cl2, where X may be Br and Cl, but it should be noted that it cannot be F, because fluorine never undergoes disproportionation reaction, as it is the most electronegative element and it is the strongest oxidizing agent. So F2 in dilute NaOH will be converted into F minus and OF2, and in concentrated NaOH this will give F minus and O2. Now let's take another example of the redox reaction, which is comproportionation reaction. In the comproportionation reaction, different oxidation state of an element will be present. For example, in NH4NO2, nitrogen is present in -3 and +3 oxidation state, and it is converting into 0 oxidation state in the N2 elemental form. So definitely we can say that in these reaction, we can say that the comproportionation reaction is the reverse of disproportionation reaction. So we can say that it is the case in which an element form two different oxidation state gets converted into single oxidation state, as I explained in this example. Now this is to be noted that we can have the range of the oxidation number, so it is very easier to identify the oxidizing agent. For example, all the oxidizing agents are present in the highest possible oxidation state. So if we wish to find the oxidizing agent, then it will be corresponding to the maximum oxidation number, and the maximum oxidation number will be equal to the group number according to the Roman periodic table. This is the range of oxidation state, that the maximum oxidation state will be equal to the group number. So if an element in a compound is present in the maximum oxidation state, it will always decrease in oxidation number, and the element in the compound which can show the decrease in oxidation number will always act as the oxidizing agent. For example, in CaMnO4, manganese is present in the +7 oxidation state. In the dichromate, chromium is present in the +6 oxidation state. In HNO3, nitrogen is present in +5 oxidation state. In H2SO4, sulfur is present in +6, and HClO4 chlorine is present in +7, which is the respective highest oxidation state of the given elements. So these elements only can show the decrease in oxidation number. So these always acts as a oxidizing agent. Now how we can identify the reducing agent? So you know that in the reducing agent, the compound is present in the lowest possible oxidation state, and it is to be noted that the minimum we are saying is lowest, not the minimum. So minimum oxidation state will be equal to group number -8, group number -8, which is according to the Roman form of periodic table. So if we wish to find that H2S is reducing agent because sulfur is present in -2, so reducing agent can increase its oxidation number. So the maximum oxidation state of sulfur is +6, right? So S-2 increase in its oxidation number, so it will act as a reducing agent. In the same way, this is ferrous sulfate. You know that the ending suffix is OUS. So ending suffix is OUS, so it will always act as a reducing agent. While in oxidizing agent, the suffix IC will be used, right? So this is ferrous sulfate. So iron is present in +2 oxidation state, and it can increase its oxidation number to the +3. So definitely it will act as a reducing agent. Now what is mean by disproportionating agent? When an element is present in the intermediate oxidation state, definitely it can increase its oxidation number as well as decrease in its oxidation number. Let's take an example like HNO2. In HNO2, the nitrogen is present in +3 oxidation state, but we know that the maximum oxidation state of the nitrogen may be +5. So it may increase from +3 to +5. So this will act as a reducing agent. On the other hand, the minimum oxidation state of nitrogen, because nitrogen belongs to the group 5th according to the Roman form of periodic table, so 5 - 8, it will be -3. So definitely it can move from +3 to -3, so it can show the decrease in oxidation number, so it will act as an oxidizing agent here. So definitely it will act as a disproportionating agent. So in the same way, we can give the complete explanation for the H2SO3, in which the sulfur is present in +3 oxidation state. Sulfur is present in +4 oxidation state actually. So it can increase in the oxidation number and decrease in oxidation number according to the group number and according to the range of oxidation number. So this is the way by which we can solve the problem based on this. So if you like this video, then like this, share it and subscribe it.